Hey everybody, thanks for tuning in with me again. Doing another segment on synergetics and nuclear structure. Today we're going to talk a little bit about the unified field and relating the force of gravity to the force of the strong force, which is approximately 10 to the 39 times as strong as gravity. What was Einstein trying to do when he wrote that unified field theory? He was trying to identify and define mathematically the differences and the similarities between electromagnetism and Maxwell's equations and gravity and Newton's equations. And some people feel that he did a fairly successful job at this. Others maybe thought not so much so. It was interesting though, because some people right after Einstein published his paper, Kaluza and Klein, they came up separately with some alternative theories about how to unify the field of electromagnetism and gravity. And what they did was they added another dimension, a fifth dimension, into the mathematical framework, and this seemed to elucidate and simplify some of the problems or whatnot. Einstein at first looked at this and approved, and then later on disapproved, and flip-flopped back and forth, I guess, from what I hear. I don't know, I wasn't there. You know, I'm just telling a story. I'm just explaining how I came up with what I came up with. So, Eddington explains real well. I'm not trying to digress. This is some very interesting stuff. So Eddington, he talks about in fundamental theory about the phase dimension. And he and Einstein both understand this phase dimension, and what that has been misinterpreted then is the dimension called time. So time's not a dimension, but phasing is what occurs in time in that infratunable super small space that we can't see during the destructuring, restructuring process between energy and matter. So when Eddington talks about the phase dimension, what he's talking about, I'll give you a model, is how, remember, we're talking about pre-time, pre-size, and that's why we have models in synergetics that are helping to understand this type of thing. He's talking about how these energies will phase transition from one place within the spectrum to another place within the spectrum. Now, nobody's ever seen a model and explained the way I'm going to you today, so I want you to kind of pay attention. I'm getting kind of close here. Each of these vectors, there's 36 vectors here, and all these vectors can move continuously through this spectrum to create a toroidal movement, a torus. So what happens is, let's just take a look at one individual vector, and they all move this way. This vector then can transfer itself by this point sliding along this edge and this point sliding through the center. Now when this vector point slides through the center and this one slides through here, you'll notice that they can do it without ever leaving the path of the other vectors, giving us 6 degrees of operational freedom, plus or minus, for 12 total degrees of operational freedom. It's not 12 dimensions, but it's 12 movements which we can make from the center of the 6 axes. So once again, I want you to pay attention. This vector here moves through, and then it continues moving through, so that this part moves 120 degree arc, and this part moves 180 degree arc. So this has a 180 degree or a half spin twist, showing how energy vectors have both a half spin twist and a 120 degree twist, or a 1/3 of a twist around the outside. Remember, synergetics accommodates both linear acceleration and angular accelerations in universe, and this shows how one vector has both linear acceleration through the center and angular momentum around the outside. As all of these vectors are moving this way, you'll notice then that we have energy coming into the center, to the outside, and spinning around the outside in its various ways, creating that torus. So each time one of these is phasing and transitioning through the structured process destructuring, bam, now it's structured again, and in that continuum, we cannot mistake that for other dimensions. So when Kaluza and Klein decided that these are other dimensions that are happening, because time's another dimension, and then Eddington discovers a phase dimension, and the mathematical models work out to seem to simplify this electromagnetism and gravity, we went off onto a very long path called string theory, which has ended up with 11 dimensions now, and M theory, and even more dimensions than that. What's interesting about that is that, see, I came upon a lot of this after I studied synergetics and started formulating my equations, which basically create unified field equations, where we equate one aspect of nuclear structure as matter to another part as force, right? One aspect, because force and matter are different aspects of the same thing. That's what energy equals mass. Energy equals mass times the speed of light to the second power, right? So that's Einstein's famous equation. Now we're seeing at the fundamental levels of things how forces of energy vectors are transforming themselves, right? Simply through mathematical equations. Planck's constant, the fine structure constant, blown up to these high powers, is equal to the mass of the neutron. You'll find my amazement then when I'm reading these books about synergetics, and you know, I'm want to read just a pinch second, because you'll get what I'm talking about. All throughout this is talking about things that 35 years later, people like Shin-Tung Yao in The Shape of Inner Space are talking about, and only bumbling so, just grasping in the dark to try and understand it. He talks about 12 universal degrees of freedom, right? And he talks about how each point has 6 positive or 6 negative moves that can be made. 6 positive or 6 negative degrees of freedom. There's 6 vectors for every point, and the behavioral interpatterning frame of reference of the 6 degrees of freedom in respect to omnidirectionality is, of course, the vector equilibrium. So he's writing about all this stuff. I'm formulating all my models. I understand what he's talking about, right? With the transition phasing and the movements, both positive and negative, that these energy vectors can take. And then that was published in 75, Synergetics was. This was published in 2010, Shin-Tung Yao, The Shape of Inner Space, String Theory and the Geometry of Universe's Hidden Dimensions. No hidden dimensions, guys, just one phase transitioning dimension which occurs in time. See, time is a tool which the human mind uses in order to categorize its linearly aggregated experiences. And so that is why we can enter time into our equations to understand how long it takes to do something, rates of speed, etc. But it's not another dimension. It's an aspect of our minds which are putting these things into sequences. So this is what I read then, long after I study synergetics. He talks about how these vectors are bundling, right? And he says, now bundles are defined as groups of vectors attached to every point on the manifold. Now he hypothesizes, because we still are mistaken in our current mathematics, that there's an infinite number of points on a sphere, but there are not. So he talks about bundles as groups of vectors attached to every point on the manifold. Notice how these vectors are attached to every point on the manifold at the center, and then as it expands they continue to do so. This is not exactly what he's talking about, but what I'm getting to then is, he talks about the tangent bundle of a 6-dimensional Calabi-Yau similarly is a 12-dimensional space, with 6 degrees of freedom in the tangent space and another 6 degrees of freedom in the manifold itself. So their explorations are only finally 35 years later slowly, bumblingly catching up to synergetics. I often thought that Buckminster Fuller and synergetics was 100 years ahead of his time. And now I wonder, well, are we not going to find this stuff out except bumblingly through string theory 100 years from now or 1,000 years from now? So that's why the import, when I'm finding things like, here's the flop transition. They're taking a look at this thing here and they're understanding that these energies are splitting, and it's a splitting in the fabric of the space-time continuum, and it's flip-flopping, transitioning into this. So notice how that's almost identical to the flip phase transitioning that I've shown you guys in this jitterbug model, wherein it transforms into all the different shapes we showed. But what I want to show then is, see how the flip-flop transition is not a split in the space-time continuum is simply bivalent vectors splitting into their univalent vectors and then transforming a part of this jitterbug transition phasing, which we've already learned about in energetic vectorial geometry. So the flop transition is just something that he has found one aspect of within the planar dimension. I wrote something down here which kind of may draw light on our situation. Oh, that's crazy. Well, that's okay, guys. That's happened before. I'll put that right back up and just continue. That's funny. I guess I had to laugh. Okay. Please pay attention. Some on board's erased right now. It's all right. Okay, so see, mankind is creating imaginary dimensions to try and make sense of the flawed mathematical models which he's created, using imaginary numbers such as the second root of negative numbers which do not exist, and using irrational and irresolvable constants such as pi in order to measure our geometrical data. Add to this the miscalculations based on the incorrect assumption that there are an infinite number of points on the surface of a sphere, and the misassumption that there's 360 degrees of angular orientation around each point. And we understand that this is how mankind mathematically deduces these imaginary dimensions which do not exist in the real world. So Kaluza and Klein went off onto the string theory with their fifth dimension, helping to explain the unification of electromagnetism and gravity. These are mathematical models. They still didn't explain the two new forces, the strong force and the weak force. So Solomon and Weinberg, they unified the electromagnetic force with the weak force. And we're still left with a difficult understanding of why gravity and the strong force ratio at approximately 10 to the 39 power. So I study synergetics, right? I create these field equations, and they really seem to show us something. They show us, once again, a little bit about how relativity theory and electromagnetism, right? Electromagnetism with the fine structure constant, and quantum mechanics with Planck's constant, and particle physics with the masses of the proton, the neutron, and the electron, along with their megaelectron voltages. We haven't deduced everything here, right? I'm just one man trying to pick at this puzzle. And I think I've come up with so much more than they have, only by studying synergetics and then studying their numerical data and putting things into a holistic map. I remember reading a book, I forget what it was called, but it explained that hypothesized, one of these real smart physicists who wrote these books. He says when the unified field's found, it's going to be a type of geometry that high school students can understand. It's going to be resolving our equations in whole rational units with basic mathematics. It's going to be able to give an explanation of the strong force compared to gravity. And he went on with a few other things, which I'll be honest, I don't quite recall. And I'm not saying that we've simplified or completed everything, but what is it, Occam's razor? We want to find the simplest solution if we can. This is the simplest solution based on an understanding of energy patterns which transform themselves into various shapes, holding and losing various amounts of quanta energy and volume. This is very, very powerful. Watch all of my videos. So see what we have here then? We have these mathematical ratios which show how pre-time, pre-size, the total number of energy vectors in these polyhedrons is being capable of transforming the numerical properties just from the force into matter. So we're getting some really cool readings, right? This number is equivalent to this number minus the proton's value, and that's equivalent to the neutron's number. And these numbers are multiplied by these numbers in order to get the total number of vectors in this tetrahedron. That's the tetrahedron with 3,677 spheres to its edge length. when we have all of these different equations in whole rational units in basic mathematics, relating Planck's constant and the fine structure constant, and the mega-electron voltage of the free neutron's binding energy, with the electron, proton, and neutron ratios, I think we've really come upon something. Once again, I'm just going to explain real quickly, like I did in my last video, about that whole thing about gravity and the strong force. Now, if we are getting a map or model of the energy structure within the nucleus of the atom by these number patterns that I've deduced, then we really may be understanding why gravity is 10 to the 39 times weaker than the strong force. Gravity times 10 to the 39th power is equal to the strong force. We're also going to remember that the universe is approximately 10 to the 26 centimeters large. And if you take one proton out of it by subtracting it out, which is 10 to the negative 13 centimeters, you get 10 to the 39. That's what Arthur Young showed us in the reflexive universe. So, the amount of energy it takes to dislodge, right, or transition phase one electron, we saw how phasing worked with that, right? It phases from one discrete state to another. And it takes just a small amount of energy on the outside of the atom to transition phase the electrons. But inside the atom, in order to bind the neutrons, we need massive more than this amount of joules of energy. We need Planck times 10 to the 34, which shows up in our alpha scale, right? And our Penn scale, and the total number of vectors in there. And then it shows up as h times 10 to the 37, right? In our quanta scales wave embracement field, 7354, which shows us how the transformation works, right? We've got this energy transforming into this mass. The neutron's mass comes from Planck's constant and the fine structure constant. And then you have the other data point, which is Planck's constant times 10 to the 40. So now we've really gotten to that 10 to the 39 ratio of force, which we're trying to get to in order to understand, simply with basic mathematics, why the structure within the nucleus of the atom has such binding power. Because I went over this once again before, I'm going to leave us with that, and I think I'm just going to briefly kind of show us this tensegrity structure right here, and I'll remind us about its properties a little bit. So, when you have this tensegrity icosahedron, if two of the quarks, remember 3 up quarks and 3 down quarks, 2 in one and 2 in one in the other, right? When these quarks start to expand, action at a distance, see how all the others move? They expand, the others expand. Well, you can only go so far until the tension and integrity of the system says, I ain't going no more. And then those magnificently strong forces, which are stopping this thing from just falling apart, because it's got the gravitational field, plus the energy structures. And I think we have, once again, a little bit better understanding of why the intercoherent forces within the nucleus of the atom are so strong compared to the force which simply relates to masses in accord with Newtonian physics. I think that's about all I was going to talk about. I'd like to take a quick peek at my notes and just remind myself. Yeah, that does pretty good, you guys. I hope you enjoyed the show. I still have one more lecture. This is kind of like part B for the last one. I'm doing one more lecture basing, explaining leveraging, compound curvature and stuff like that in accord with the forces that we're measuring inside the nucleus of the atom. And then I'll do one summing kind of everything up, explaining how the universe is alive and conscious. Thank you very much for joining me. I hope you can understand and appreciate my frustration, but also my attempt to explain. See, when we read these books by these other people, and I'm not trying to be mean, but they are running through this and saying, you know, like Stephen Hawking says, you know, we're just going to have to accept all these different theories. We can't unify everything into one simple theory. But I think if we understand the energetic vectorial geometry of synergetics, we may really be onto something. Thank you very much for your time, you guys.